In this problem, an SUV that has a mass of 2,000 kilograms is accelerated from rest, and they tell us the rate of acceleration. So here's the SUV, and it's driving along the road. So what they tell us is that it's accelerating at a rate of 3 meters per second squared. And they tell us the total force resisting its motion is 1,500 newtons. Total force resisting its motion would be probably primarily air resistance. It's a combination probably of friction and air resistance, but when you're driving quickly, the largest force resisting its motion would be air. So I mean, you would be fair to say, well, what about friction? I think that's a smaller value compared, because the wheels are rolling on the pavement, that's a smaller value, but it certainly exists. In this problem, they only want us to consider the force of air. So obviously there has to be some force that the engine provides in order to overcome that air force, in order to get it to accelerate. You can call that whatever you want. You can call it force applied. You can call it the force of the engine. You can call it, I don't know, whatever you want to call it. When we do Newton's third law, we'll talk about what it exactly is. But those are the two forces acting. Again, we'll pick the positive direction to be forward, the negative direction to be backward, and we're going to solve this exactly the same way we solved the last two, which is F net equals MA. MA equals the sum of the forces. And now, in this case, the sum of the forces is FA plus negative air, right? F air. So we know the mass, we know the acceleration, we know the air. All we have to do is find the applied force. So we'll plug everything in. 1,500 times 3 equals FA minus, oops, did I do that wrong? It is 2,000. So this number is actually 2,000. And then this number is 1,500 for the air resistance. And when you rearrange and solve, you get the value of 7,500 newtons. Okay, and this is question number 3 on the problem. We can actually look at question number 4 because it's very similar. We'll do it together. Question number 4, the problem says, okay, so you can picture it. The SUV is sort of accelerating up until it gets to whatever. This one says it's going 18 meters per second. And but now the force resisting it has increased. So it's asking us the new question. So here's our same SUV, and now what they're telling us is the force. So now it's traveling at actually a constant speed of 18 meters per second. Constant, right? The question actually says driving at a constant speed. This should be red flags for you. This should set off alarm bells in your mind when you see constant speed. What you're thinking, what you should be thinking, and what you hopefully will start to think is A equals 0. When you see A equals 0, you think F net equals 0. Okay, that's kind of like the big takeaway from Newton's first law, is if you've got a constant speed, the forces have to be balanced. So if they tell you that the total force resisting its motion is 2,500, so now the F air is 2,500 newtons. You can, I mean, most of us now, if we know that the forces are balanced, we can look at this and say the applied force must also be 2,500 newtons. So you might still have the temptation to think, how is that possible that it's moving and the forces are balanced? Remember, when it was accelerating, the force had to be greater than the air resistance. But once it reaches its maximum speed, in order to maintain a constant speed, that forces have to be balanced. And therefore, these two forces have to be equal in magnitude and opposite in direction. And that's why the applied force is now is 2,500. The engine, so the answer would be the engine exerts 2,500 Newton force. And here the engine exerted 7,500 Newton force. The idea being, in order to actually make it accelerate, it's got to apply a much greater force Once it's going at a constant velocity, it just has to maintain that constant velocity.